This portion of the presentation covers the new Safe Confinement conceptual design. This movie was prepared using a 3D CAD model. It presents the current design status prepared by the team of engineers from Bechtel, EDF, Battelle, and the Ukrainian subcontractor KSK. At this time, the conceptual design is complete and the tender and licensing documents are under preparation. The main purpose of the NSC arch is to confine the radioactive materials and limit the rainwater incursion, as well as to initiate the deconstruction activities for Unit 4 of the Chernobyl nuclear power plant. The construction work on site begins with the arch foundation. The foundation work begins in the erection and sliding areas, thus allowing the erection work to begin as soon as the sliding paths are completed. Then the work extends toward Unit 4. The foundation consists of a 3 to 4 meter thick by 18 meter wide concrete pile cap supported by deep concrete walls, shown here in the cross section. The contaminated topsoil layer will be removed prior to construction of the foundations, thus minimizing schedule risk and radiation exposure to workers. As soon as the assembly area is ready, the arch construction work begins. The arch structural elements are pre-assembled in a shop and brought to the assembly area. The elements are as big as possible to minimize the assembly work on site. Some may be 65 meters long and may weigh up to 200 tons. The design team considered the use of a large crane to erect the pre-assembled elements. This was presented in our previous movie of the conceptual design in March of 2003. An alternative method has now been considered, using strand jacks for the erection of the arch. In this method, the arch elements are assembled into large sections on the ground. Each section consists of 3 arch bays. The end sections are pivoted on the foundation support and lifted by the strand jack towers. The middle section is then assembled, lifted by the strand jacks, and connected to the end sections. The strand jack towers are then moved inward to clear the arch. After completion of the first 3 bays by this method and erection of the east wall, the first quarter of the arch is moved eastward. This short sliding clears the erection area, now permitting the erection of the subsequent 3 base sections of the arch. The erection activities shall be conducted as much as possible in the assembly area. That will include the installation of the bridge cranes, end walls, and cladding in the arch structure before the sliding. Once the entire arch is assembled, it is moved over the object shelter. The structure is supported by steel distributing beams sliding on Teflon bearings. The pulling jacks are located at both far east ends of the sliding paths. A high-precision hydraulic integrated system controls the sliding forces applied on both sliding paths, allowing for a smooth movement. The final sliding is expected to last less than a day. It should also be noted that both the east and west walls are shaped so that they can be moved over Unit 4 with minimal additional work in the final resting place. After full commissioning of the arch, the deconstruction work can begin. The first structures that can be dismantled are the roof's shelter components, the southern panels, southern hockey sticks, northern hockey sticks, and the eastern hockey sticks. Finally, the dismantling of the main beams takes place. The northern B1 beam, then the southern B1 beam. The deconstruction of the southern B1 beams shows the flexibility of the cranes. Beam B1 South is first lifted from its east-west position and then turned in the north-south direction using the capabilities of the trolleys to move from one bridge to another. Finally, the southern B1 beam is placed in the laydown area in the north-south direction. This flexibility of the cranes allows the rotation of the dismantled elements, thus reducing the arch length by 5 meters. Next, the mammoth beam can be deconstructed. The dismantling of this heaviest beam requires cutting it into 2 sections, which in turn will require an additional support. This video shows a temporary support tower. If this approach is not feasible due to instability of the deaerator stack, an additional bridge trolley can be used to provide the middle support. Next, the central hull is removed. Each dismantled structure will, from this point, be processed in the auxiliary storage buildings and eventually stored in the temporary storage designed under the arch. We hope that this video provides you with a clear idea of the work and progress being accomplished currently under the Chernobyl SIP project.